Okay, today we're going to talk about section 8.4, simplifying rational expressions. Okay, remember, rational expressions can only be simplified. An expression cannot be solved because it's not set equal to anything. A rational expression is defined to be a polynomial over another polynomial. So let's look at example 1. We're going to simplify, and we're going to state restrictions on the variable. All right, trying to write neat on here. Okay. So we're going to go x. Let's try this. X squared minus 2x divided by x squared minus 4. Okay, the key to everything here is factoring. In the numerator, I'm going to take out an x. So I'm left with x times x minus 2, and the denominator is the difference of squares. So I have x plus 2, x minus 2. Okay, now to look at the restrictions on the variable. I see that the x minus 2's cancel out, but we have to do our restrictions on the variable on the original expression before we simplify. So I know that x cannot equal positive or negative 2. Okay? Each one of those will make my denominator 0. Now I'm going to simplify, so I can cancel out the x minus 2's. Now remember, you have to cancel entire polynomials with entire polynomials. You cannot cancel this x with that x. Okay? The bottom x is part of the polynomial x plus 2. It can't be canceled. Polynomial can't be separated. So my reduced fraction is x over x plus 2. And I simplified the expression and stated the restrictions. Okay, let's look at another example. Example 2. This one looks complicated, but it's really not. 3x minus 5x squared minus 2x to the third times 6x squared minus 5x plus 1 all to the negative 1 power. So if we remember correctly, anything to the negative 1 power simply moves it to the denominator. So we actually do have a rational expression here. The 3x minus 5x squared minus 2x cubed stays in the numerator, and the 6x squared minus 5x plus 1 moves to the denominator because it's to the negative 1 power. Okay, now I'm going to go ahead and write my polynomials in standard form. I'm going to rearrange the numerator to be negative 2x cubed minus 5x squared plus 3x. And the denominator is 6x squared minus 5x plus 1. Okay, remember what I said here. The key is in the factoring. Factoring is one of the most important things that we've learned in all of Algebra 2. So I think in the numerator I'm going to take out a negative x, because I like my leading coefficient to be positive. So that would leave me with 2x squared minus 5x plus 3. Whoops, got my x. And in the denominator, I would have 6x squared minus 5x plus 1. Okay, I'm going to continue to factor. This numerator factors into 2x minus 1, x plus 3, over 2x minus 1, 3x minus 1. Okay, now that I'm in completely factored form, I'm going to go ahead and state my restrictions. Sorry about that. Now that I'm in completely factored form, I know that x cannot equal 1/2 and 1/3. Now I'm ready to reduce my fractions. This 2x minus 1 can cancel with the 2x minus 1, and nothing else cancels. So my reduced fraction is negative x times x plus 3 over 3x minus 1. People ask me all the time if you have to distribute the negative x back in. No, I like it in factored form because it's easy for me to look at the problem in factored form and see that nothing else cancels. If you started distributing things back, it would be very difficult to see if things cancel. Okay, let's take it a step further. Example 3. 3x squared minus 6x over x squared minus 6x plus 9 times, x squared minus x minus 6 over x squared minus 4. Okay. Like I said, the key is factor, factor, factor. Factor everything you can. So if I look at the numerator of the first fraction, I can take out a 3x. So that leaves me with x minus 2. The denominator is a perfect square trinomial. It's x minus 3, x minus 3. On the second fraction, the numerator factors into x minus 3, x plus 2. And the denominator is x, difference of squares, x plus 2, x minus 2. Okay. Now you can cancel across a multiplication sign. You cannot cancel across addition and subtraction. But first thing we want to do is state our restrictions. What can x not equal? And remember, you have to do your restrictions before you cancel anything out, because you have to make the original problem exist. So if I look at my denominator, I see that x can't be 3, x can't be 2, and x can't be negative 2. So now I'm ready to go ahead and cancel. So one has to be in the numerator and one has to be in the denominator to cancel. So this x minus 3 cancels with either one of those x minus 3. This x plus 2 cancels with an x plus 2. As long as one's in the numerator and one's in the denominator, they can cancel. And this x minus 2 can cancel with that x minus 2, leaving my simplified fraction to be 3x over x minus 3. See, this isn't difficult. Okay. Oh, I keep shrinking it down on accident. Come back. That's a little too big. There we go. Okay. Example 4. We're going to have a lot of variables here. 6y a squared divided by 3y over a cubed times x. Okay, not much to factor here, so let's talk about our restrictions. We have a bunch of variables here. Okay. Now, before I take that back, before talking about restrictions, if we remember correctly, dividing by a fraction is the same as multiplying by its reciprocal. So I'm going to change this to 6y over a squared times a cubed x over 3y. Okay, so now let's talk about all the restrictions. It's kind of complicated on this one because the original problem has to exist and it has to exist when I flip it over. So let's look at the original problem up here. Okay. In this problem, this is telling me a can't be 0 and x can't be 0. Otherwise, both denominators would be 0. Now in this down here, when I flipped over the fraction, guess what now? Y can also not be 0. Because if y were 0, I wouldn't be able to flip over my fraction at all to do the multiplication. So those are my restrictions on my variables. I've got 3 variables. I've got a restriction on each one of them. Now, just because you have 3 variables doesn't mean everything has a restriction, but in this case it does. Now we can start canceling away. This a squared can cancel with this a cubed to be a. Now the x's can't cancel because they're both in the numerator. This y can cancel with that y. This 3 can cancel with this 6 to be 2. And then if you remember fractions, you multiply straight across. So I'm going to multiply straight across the numerator, would give me 2a and an x squared, because I have an x and an x. And in the denominator, everything canceled. So I guess it's over nothing. 2ax squared. And that's my simplified fraction. And we already did our restrictions over here. Sorry if this is messy. I'm doing my best right on the touch screen. Okay, one more example. This one I'm going to give to you in factored form because I want to show you something special about this one. Plus times x plus 4 over 3 minus x. Okay, so if I look at my restrictions on my variables, what can x not equal? Well, x can't equal -4, and x cannot equal 3. All right, now I'm going to start canceling, but something funny happens with this one. This x plus 4 could cancel with this x plus 4. Okay, now the 3x, we wish the x minus 3 and the 3 minus x would cancel. And we actually can cancel them. But what they do is they cancel leaving a -1. And I'm going to show you why that's true in a minute. So what I now have left in my simplified fraction is -1 times x plus 2, which is simply 2. Let's erase that. If I wanted to distribute it, you don't have to. -x minus 2. Okay, so why do the x minus 3 and 3 minus x cancel, leaving a -1? Let's talk about that. Suppose, let's do it in terms of numbers. Suppose I had 5 minus 3 divided by 3 minus 5. I switch the order, and one's in the top and one's in the bottom. Well, what is the numerator? The numerator is 2, the denominator is -2, so they divide to be a -1. It happens anytime you switch the order. Whoops. If I did 5 minus 8 over 8 minus 5, oops, better hurry this up, I would get negative 3 over 3, which is negative 1. So therefore, x minus 3 divided by 3 minus x is negative 1. Okay, that's it. Good luck. Do the worksheet. See you tomorrow or the next day. Bye.